Physics Pot 423. This frequency is in the radio frequency RF, bandwidth of wavelength shorter than about 10 centimeter. A short time after the incident pulse has ended, the nuclei will return to their equilibrium state, emitting RF radiation. The short time between the end of the RF pulse and the re-emitting of the radiations is known as relaxation time. The whole process is referred to as nuclear magnetic resonance, NMR. In practice, there are two relaxation processes. It is time between the two that forms basis of the magnetic resonance imaging, MRI. Since hydrogen is abundant in body tissues and fluids, hydrogen is the atom used in MRI. MRI, magnetic resonance imaging. A schematic diagram of the magnetic resonance MRI is shown in the figure. It has got its display and gives you all the detail. The patient who is to be investigated is positioned in the scanners between the poles of the large magnet that produces a very large uniform magnetic field in excess of 1 Tesla. The magnetic field causes all the hydrogen nuclei within the person to process with the same Larmor frequency. In order that the hydrogen nuclei in only one small part of the body may be detected, a not uniform magnetic field is also applied across the patient. This not uniform field is accurately calibrated and results in a different magnitude of the magnetic field strength at each point in the body of the patient. Since the Larmor frequency is dependent on the strength of the magnetic field, the Larmor frequency will also be different in each part of the patient. The particular value of the magnetic field strength together with the radio frequency that is emitted enables the hydrogen nuclei in the pot under investigation to be located. Radio frequency RF pulses are produced in the coils near the patient. These pulses pop into the patient. The emitted pulses are produced as a result of de-excitation of the hydrogen nuclei are picked up by the coils. These signals are processed and displayed so as to construct an image of the number of density of the hydrogen atoms in the patient. As the non-uniform magnetic field is changed, atoms in the different parts of the patient's body are detected and displayed. An image of the cross-section through in the patient may be produced. One such image is also shown in the figure. A whole series of images of sections through the patients can be produced and stored in a computer memory. As with CT scanning, this enables a three-dimensional image to be generated. Section through the patient may be viewed from many different angles. We've got an example for you. The use of magnetic resonance imaging is now a common diagnostic tool in medicine. However, there may be disadvantages for some patients. Suggest why. A. Some people may find the scanner to be claustrophobic. B. There are additional problems when scanning young children rather than adults. Well, it's a very important thing that they have said that the patients in the scanner can be claustrophobic. Yes, claustrophobia is really a disease. Many people suffer from it. I also suffer from claustrophobia. My wife also suffers from claustrophobia. We all suffer from claustrophobia. So claustrophobia is certainly one of the great hurdles to these MRIs. great issue for MRI.